this is the ethane molecule. This is the ethane molecule. They find that the angle inside this is 120 degree, one thing, 120 degree. They also find this to be a planar molecule. They find this to be a planar molecule. And they also there's a double bond. There's a double bond. So whenever there's a double bond, you have to explain it through hybridization, how it is a planar, how this is 120 degree. So what it says that carbon has got in the excited state one electron in the S and one electron in the P. So if it has to form a double bond and the other bonds are equal, so this P is left alone. And these sp2 they hybridize. When they hybridize, they give birth to three bonds which are equal, three orbitals which are equal, sp2 orbitals they call it. And they will do the sigma bonding. The sp2, this will sp2 will hybridize, will overlap with the s of hydrogen. This sp2 will hybridize with s, and this sp2 will hybridize with the other carbon. So similarly for the other carbon, this sp2, this sp2, and this, and the angle between them is 120 degree. Angle between one hydrogen, one p orbital, this electron is left. This is for pi bonding. This is this, and that is why planar. And there is a cloud which your book says is like this. There's a cloud for the sideways overlap. So this is the pi bond, and this is the planar structure, 120 degree. So he says uh, uh, two sigma bonds are formed with the hydrogen and one sigma bond is formed with the other carbon. And then he says, just remember, there's a sideway overlapping. This is for pi, this is for sigma, all the other is sigma. These sigma are along the internuclear axis. That means the nucleus, there's a nucleus here, there's a nucleus here, there is a nucleus here, there is a nucleus here. So they overlap along the nucleus axis. Strong bond, sigma bond, and that's the weak bond. And pi left for sideways overlapping. Naturally, it won't be so good overlap. And ethene is a planar because the maximum overlap of the p orbital that form the pi bond. And this so this is 120 degree, and these sigma bonds are equally distributed. So this explains the structure of ethene, sp2 hybridization. So we have found that in methane, they are all single bonds, all around, along the internuclear axis. There's no double bond, so no pi bond, so no p is left. All the p will mix. You get sp3, you will get 109 and tetrahedral. In ethane, there is one double bond, so one you will have to leave for, there will be one pi bond, and that you will have to leave one p left alone for pi bonding. The other p's one will overlap, make a sp2 hybridization. The other two p's and one s, they will make 120. It will be a planar molecule, and that is how we get the ethene. Ethene, we have something like this. Ethane, there is sigma bonds, all sigma bonds, no double bond, so no p is left. So they will undergo sp3, they will undergo sp3, and you will get uh, uh, this kind of tetrahedral arrangement. It's not a planar molecule. All the angles will be tetrahedral. This will be like a tetrahedral here. This will be like another tetrahedral here. And you will form 109. So this is ethane. So ethene, each has different kind of hybridization. The sp3, this was sp2 plus p, and this is sp3 in both carbon atoms. So that explains the 109-degree angle and the 120-degree angle and the bond lengths and the sideways overlapping. Everything explained through hybridization. The only way overlap can be explained and that angles could be explained by hybridization, because ss and pp uh, different angles it will give you. sp3 will be same, and it will give you same angle.